So, hi everyone, and welcome again to another video, where today's video what we'll do is compute two limits for functions of with several variables. Okay, so we'll compute first this limit and then finally this limit. So, a common technique for computing limits is first checking if the expression inside the limit is something that it's composed by continuous functions, and if so, then we will evaluate these functions unless we are committing a forbidden operation, like dividing by 0, or computing the square root of something negative, or the logarithm of 0, or so on. Okay, so we must check that we are not doing anything forbidden. Okay, in visual inspection tells us that both limits are a little bit in this case. Why so? Because both of them are divisions. The numerators and the denominators are expressions of continuous functions, but because in both of them x and y go to 0, 0, the denominators of both limits go to 0. So, and because we cannot divide by 0, okay, we cannot evaluate and say, okay, the limit is what is on the numerator divided by what is the denominator. So we are forced to do it a little bit better. So let's compute the first one. So the limit when x and y go to 0, 0 of the expression x squared minus y squared, x squared plus y squared. Now, a common technique for computing these limits is using polar coordinates. So polar coordinates is when we write x in terms of rho cosinus theta, y is equal to rho sinus theta, and then we first must understand what does it mean in terms of polar coordinates that x and y goes to 0, 0. So x and y goes to 0, 0 means that the point goes to the origin. And in polar coordinates, because rho is the distance between the point and the origin, and theta is the angle between the point and the positive x-axis, that x and y goes to 0, 0 is equivalent in polar coordinates to rho going to 0. So theta doesn't play a role in the limit, in the sense of saying theta doesn't define, it's not that theta goes to pi or 0 or to pi or pi halves whatsoever. No, it's just that the equivalence of x and y going to 0, 0 is rho going to 0. So, and as always, we know that x squared plus y squared is equal to rho squared. And that's useful because notice that we get the rho squared here. So the limit is equivalent to this rho squared, and then we get rho squared of cosine squared of theta minus sine squared of theta. So if we substitute, we get this. Notice that we already factor it out, rho squared from both here and here. So the rho's go to 0, then we are left to the limit of cosine square of theta minus sine square of theta. But question is, what is cosine square of theta minus sine square of theta? What is it? It's cosine of 2 theta. It's cosine of 2 theta. Okay. Here what we have used we call that cosine of a plus b is cosine of a times cosine of b minus sine of a cosine of b. Okay, so, and then when a and b are equal, so we get cosine of 2 theta is equal to cosine of theta times cosine of theta, cosine square of theta, minus sine theta, that is sine square of theta. Very good. So the limit is, when rho goes to 0, of cosine of 2 theta. Okay, so how to deal with this? So rho goes to 0, and there is no rho here. So theta can do whatever it wants. So theta is free. Okay, so as the point goes to the origin, it can spin around. It means that theta is changing. It can stay theta fixed. Doesn't matter. Okay, so this tells us that the limit does not exist, because theta equals to 0, we get that the limit is equal to 1. Theta equals to pi halves, we get that the limit is cosine of pi, that is minus 1. Okay, but let's analyze it again, this limit. Okay, so let's see if we can, now using polar coordinates, it gives us a hint. So another way for exploring if the limit exists is by taking different sequences of x and y's that goes to 0, 0, and if we get two different limits for two different sequences, then the limit does not exist. Okay, so if we are able to construct two different sequences that goes to the origin, such that the limits are different, then we can proclaim that the limit does not exist. The first two sequences that one tries are when the point approaches to the origin through the x-axis, and when the sequence approaches to the origin through the y-axis. So the first sequence is this one, and then the limit transforms when n goes to infinity of what? 1 over n squared minus 0, 1 over n squared plus 0. And this divided by this is 1. The second sequence is when the sequence approaches to the origin through the y-axis. And now we get minus 1. So this and this are different, so the limit does not exist. Okay? So there are two ways. We can summarize that this problem, there are two ways of solving it. One is like a more systematic way, that is using polar coordinates. So we use polar coordinates, we substitute, simplify as much as possible, and see if we get something that does not depend on theta and tells us the limit. In this case was not correct. This was not the case. The other possibility is trying to get two different sequences that gives us the limit, different limits. A third possibility for solving this problem is that first one tries with different sequences to see if one gets a feeling of if things are converging or not. And then if so, if you see that for all sequences that you try is converging, then you try to prove that it converges by using, for example, polar coordinates and computing it. Otherwise, you already got a counterexample, two different sequences that converge to two different values. Okay, so let's compute the second limit. The second limit So I built it because it will give us a way of saying, okay, not always the usual polar coordinates will help us solving the problem. Because if we use polar coordinates, what's the problem? So recall that the origin of our pain for computing these limits is the denominator. So we must control the denominator, the better, the best. Okay? So we must control it. In case of having x squared plus y squared, by substituting with polar coordinates, we get rho squared. So there is no theta. So instead of two variables, we get one variable. That's good, because transforming our problem into a one-dimensional problem is always good. Because recall that in several variable calculus, one comes from one variable calculus. And there we knew quite well how to compute limits. But the problem here is that if we use these ones, then 3x squared plus 5y squared will depend on rho and theta. Will depend on rho and theta. And we don't want this. So we need to tweak these coordinates. This change of coordinates. So we get something manageable. So 3x squared plus 5y squared does not depend on theta. That's what we want. That's our target. That's our goal. So notice the following. So if x square root of 5 rho cosine theta and y is square root of 3 rho sine theta, 3x squared plus 5y squared is what? 3 times this squared, this squared, this squared. Now, 5 times this squared, this squared, this squared. Now we can take as common factor 3, 5, rho squared, 5, 3, 5 squared, that is 15, rho squared, and then we get cosine squared plus sine squared. And this is equal to 1. So we get 15 rho squared. 15 rho squared. Good! Now substituting this into the limit, again the limit now is rho goes to 0, which will not depend on theta. Okay? And then x was this, y was square root of 3 rho sine theta, and downstairs in the denominator we had 15 rho squared. Now, notice that we can factor out rho in the numerator. So we get rho, 15 rho squared, and then we get square root of 5 cosine theta minus square root of 3 sine theta. Rho divided by rho squared rho divided by rho squared is rho. So again we get up to this point and we see, well, there is 1 over 15 rho. When rho goes to 0, this goes to infinity, and this depends on theta. So the limit does not exist, because depending on which choices we pick of theta, so if this is equal to this, then this vanishes. If not, then it goes to infinity. Okay? Again, now, if one is interested, one can use the sequences. So we had this limit, where was it? 3x squared. X squared plus 5y squared. So if we choose, as I say, 1 over n, 1 over n, then the limit, n goes to infinity, because we have x equals to minus y, the limit is 0, because the numerator is 0, and whatever we have here, that is non-zero. But if we choose xn, yn equals to 1 over n, 0, so now the limit is 1 over n, 1 over n squared, and this limit is equal to n thirds, that is plus infinity. So these two values differ, so the limit is 0. As a rule of thumb, let me tell you as a rule of thumb, that will help you to visualize when the limits will converge or not, or it would help you. Is, okay, so when we have a polynomial divided by a polynomial, and the denominator is a polynomial that goes to 0, and it's like x squared plus y squared, I mean it's, for example, 3x squared plus 5y squared, or it can be transformed into one of these polynomials. Then one must check the degree of the numerators. If the degree is higher than 2, then the limit will exist, and it will be 0. If the degree is equal to 2, then the limit could exist or not, it depends on if there are some magic cancellation. If the degree is less than 2, so 1 or 0, just a constant, then the limit will not exist. Okay, that's the rule of thumb, but one must check it time to time. One must check that this is the case. So thank you very much, and see you in the next video.